In this video, let us learn fused deposition modeling machine. Before moving to FDM technology, there are two questions. First question, why this FDM technology is needed, and second one is, what is the strength of FDM technology? The FDM technology provides unimagined design freedom to fabricate the component with a thermoplastic material, and this FDM uses strong and engineering thermoplastic materials to fabricate the components. Also, it can fabricate the components production ports as a functional models with outstanding thermal and chemical resistance. Also, the high strength component with a low weight ratio can be fabricated by using this FDM technology. These are the reason we need to study and we need to move to FDM technology. What are the materials can be used here? Initially, we need to know about the materials which can be used for making the component. In FDM technology, the raw material will be in the form of plastic wire, the diameter of 1.75 millimeter. Now let's see what are the materials can use here. Polylactic acid, acrylobutadiene styrene, nylon, polycarbonate, altem, and all engineering grade plastics can be used as a raw material. Next, list of components in FDM technology. List of major components. Machine bed. There are two types of bed, heated bed and normal bed. The heated bed can be used to fabricate the component from ABS and altem materials, and normal bed can be used for making the component from PLA material. Stepper motor. These stepper motors are used to make axial movement of bed and extruder. In some machines, the bed will move in X and Y direction. In some machines, the extruder setup will move in X and Y direction. And the extruder setup, in extruder setup, there will be a heating unit and nozzle. This picture shows the extruder setup. In extruder setup, this is the nozzle and heating zone and gear arrangements. Initially, the filament will be wound in the form of coil. The filament fed in between the gear. When it is fed in between the gear will push the filament into the heating zone. In heating zone, there will be a heating setup. Heating coils will be there. When the filament enters to the heating zone, it will be melted and changed to the form of semi-solid. The unmelted filament will act like a piston strange arrangement. This arrangement will push the filament, this filament delivered over the bed. This is the function of extruder setup. This is the main component of FDM technology: heating, melting, deposition. And filament spool. There are two types of filament we are using. One filament is used for making the component object for a required component. Another one is used for making the support structure. Some components there will be a wiring object, so this should be supported by using support materials. But it can be removed after the component fabrication. And machine control units. This machine control units coordinates all the stepper motors and control components, and component is built over the bed. Now let us see the construction. This is the machine bed, and this one is the object built over the bed. This machine bed is connected with the stepper motors to make axial movement. And see here, this motor is used for making the x-axis movement. This motor is used for y-axis movement. Over the machine bed, there will be a nozzle, extruder setup. Extruder setup, this is the nozzle. Heating zone here, filament spool, object spool, and support material spool. In this diagram, this extruder setup will move in Z axis. This one is our object material and this one is support material. And this is the control setup, control unit setup. Initially, we will design the component by using softwares, and this designed component will be sliced into a horizontal digital layers, and this digital layer will send to the machine control unit. This machine control unit will get the G codes from the designed component, and it will give the instruction to the Z axis, X and Y axis. So all the functions will be controlled and object will be built. That is the function of FDM technology. Now see here, this is the extruder setup. In extruder setup, there will be a heating unit. The filament will come from the spool and enters to the heating zone. Here the filament will be melted, moved to the nozzle. This filament will act like a piston wrench arrangement and pushes the melted filament into the nozzle. The material will be deposited over the bed. This is the basic concept of FDM technology. Let us see the applications of FDM technology. This FDM can be used for testing of fit and form functions. Also, we can able to make the patterns for making the casting components, and investment casting patterns also can be fabricated, and fabricate the testing components from testing models can be used here. Production of complex parts such as jigs and fixtures to check the tolerance. Every areas we can use this. What are the areas this FDM technology is currently using? Automotive sectors, aerospace, medicals, fashions and educations. In all the areas, the FDMs diversified. Now, what are the main advantages? The component can be fabricated in affordable cost and less time to produce the component, because we are designing by using softwares and directly fed into the machine to produce a component. And variety of filaments, as we discussed, number of engineering plastics can be used as a raw material, so the components can be fabricated. And easy to use. It's a very simple to use. Directly we can able to design and print the component. Even though number of advantages, there is one disadvantage, that is anisotropy property in Z direction, because in Z axis the nozzle will move one step after completing the successful layer. That height depends upon the input of our layer height. So the in between layer height depends upon the strength between the layer bonding. So in Z direction, strength will be very less compared with the X and Y direction. That is the anisotropy property. That is drawback in fusion deposition modeling machine. Thanks for watching. Subscribe and share with your friends. Thank you.